you've thought about these two, let's go ahead and go through these two discussion questions. So that first one says, can an object with a constant acceleration reverse its direction of travel? Meaning, if I have an acceleration, let's take an easy one like gravity. So if I throw this ball up, can it reverse its direction? It's going up, then it's going down, and gravity, very constant. Okay, so yes, that is possible. Can it reverse its direction twice? Okay, so to unpack this, you're thinking, okay, let's apply it to that same theory. If I only let gravity act on this and I throw it up, yes, it changes directions. Is gravity ever going to make it go back up? No, it's not. And a second way to think about that one is if I was to draw a graph of velocity versus time. Switching directions of motion means I'm going from a positive velocity to a negative velocity, meaning I'm going from a positive direction to a negative direction. I'm switching directions. I'm crossing this axis. Now, a constant acceleration means I need what kind of a line? I need a straight line. So is it possible for me to have a straight line that crosses that axis once? Yes. Does it have to? No. But it can happen. Can a straight line cross the axis twice? It cannot. Now, some of you might be thinking, Mr. Foster, just humor me here for a moment. Let's say I took that tennis ball and I drilled a hole all the way through the center of the earth to the other side. Therefore, when I drop the ball, gravity is going to cause it to go this way. And when it gets to the other side of the earth, gravity is then going to pull it back up. And it's going to come back to me, and then gravity is going to pull it back down. It's going to change directions. Now, assuming doesn't start on fire in the center of the earth and all these other things, it's going to change directions more than once. How can that happen? Well, in that scenario, your acceleration is not constant. See, as that ball falls, the acceleration due to gravity decreases from 9.8 meters per second squared at the surface of the earth to 0 at the center of the earth, because all of the mass of the earth is pulling it equally in all directions because that mass is evenly distributed around it. And then as it falls through, it gets bigger and bigger in the negative direction. And so you don't have a constant acceleration in that case. That's why that doesn't meet the criteria for this problem. All right, let's look at the second one here. Is it possible for an object to be slowing down while its acceleration is increasing in magnitude? Okay, so let's just rewrite that a couple times and see if we can figure that out. So the question is can it be slowing down at a faster rate? Faster with time. Okay. Can I be slowing down with a bigger magnitude? And the correct answer is yes here. And so the example I might imagine is when I get off the interstate, I just kind of lightly tap the brakes and then I kind of slow down due to air resistance. But as I approach that stop sign, I push on that brake pedal a little harder and a little harder, and I start to slow down faster and faster. And so that would be an example where I can slow down faster with time. Okay. The second one says, is it possible to be speeding up while the acceleration is decreasing? Okay. So is it possible for me to be speeding up at a slower speed, at a slower rate over time? And again, when we say decreasing, we're meaning it's going from some value to 0. And in order for me to be speeding up, that just means my velocity and my acceleration need to be in the same direction. And it's just saying that acceleration is getting smaller and smaller. So the amount I'm speeding up by, it gets smaller and smaller. So you can try this. You go onto the entrance ramp and you hit the gas and you're going to take off. And you're going to be speeding up from 0 to 20 really fast. But once you get up into those higher speeds, maybe you're going from 50 to 70, your car isn't going to be able to speed up as fast, and so you're going to be speeding up at a slower rate as you are getting faster and faster because air resistance is getting larger. Your car just can't deliver that same power required for that acceleration.